we start with the telescope, astronomical telescope, when the image is formed at the least distance of distinct vision. In this, the telescope is said to be in the near point adjustment. Again, it is made up of two lenses, objective and the eyepiece. The lens which is close to the object, which is towards the object, is called objective, and the lens through which image is seen is called the eyepiece. Focal length and the aperture of the objective is much larger than the focal length and the aperture of the eyepiece. The image formed by the objective lens is at its focus because the object is very far away, so the parallel rays are converge at the focus of the objective and the image eye is formed. This image acts as an object for the eyepiece, and if it is lying in between the focal length and the principal focus of the eyepiece, then image is formed at the least distance of distinct vision. AB is a final image. UE is a distance between the image formed by the objective and the optical center of the eyepiece. D is a distance of least distinct vision, which is equal to the image distance of the eyepiece. Now, this angle is alpha, this angle is beta. As you know, the magnifying power of a telescope is the ratio of the angle subtended at the eye by the final image. Yet by this image at the eye, so the angle beta, to the angle subtended at the eye by the object lying at infinity. That is, the magnifying power is equal to beta upon alpha. If the angles are small, then beta is equal to 10 beta and alpha is equal to 10 alpha. Now put the value of 10 beta. 10 beta is equal to f naught I perpendicular, that is equal to f naught I upon base, that is p naught f naught. 10 alpha, this angle, this is 10 alpha, again f naught I upon p naught f naught. F naught I cancel out and this will be the relation. P naught f naught, this distance is the focal length of the objective. PE f naught, PE f naught, this distance, it is equal to UE. As it is lying on the left hand side of eyepiece, this distance is on the left hand side of the eyepiece, so there is a negative sign. As it is a lens equation, and you know that the VE equals to minus T, U is equal to minus U, F is the focal length of eyepiece. Now it is 1 upon UE, 1 upon FE plus D. Multiplying by F naught on both the sides and rearranging, we are getting this equation. Now from this, for the large magnifying power, focal length of the objective must be greater than the focal length of the eyepiece. Also, it is to be noted that in case of M is larger than that in the normal adjustment position. Now the next is a reflecting type of the telescope. When the objective are the mirrors, then the telescopes are called reflecting telescopes. They have the several advantages. In the case of the reflecting telescopes, the images are free from the spherical and chromatic aberrations. It is free from the spherical and chromatic aberration, free from these defects. Third point, that is the telescope has high magnifying power, large resolving power, high light gathering power, due to which the image is bright. It is in case of the reflecting type of telescope, there are the two telescopes, the Cassegrainian telescope and the Newtonian telescope. Now first we will discuss the Cassegrainian telescope. This telescope was designed by Sir Cassegrain and is named after him. Here is an arrangement of the typical type of the reflecting telescope, and in this the objective is a large parabolic mirror. It is a large parabolic mirror and with a hole at its center. A small convex hyperbolic mirror is placed in front of the objective. A convex lens acts as the eyepiece. A beam of light parallel to the axis of the telescope from some distant object is incident on the objective. The objective converges this beam towards the principal focus. The reflected beam is intercepted by the convex mirror, and convex mirror forms an inverted image at the F. This inverted image is seen through the eyepiece, and the eyepiece is replaced maybe by camera or by some other recording device. The magnifying power of the telescope is the ratio of the focal length of the objective to the focal length of the eyepiece. The second type of a reflecting telescope is the Newtonian telescope. The light from the distant star is allowed to fall on a large concave mirror, which is the objective and is fitted at the end of the long tube. Before the light is focused, it meets a small plane mirror inclined at an angle of 45 degrees to the axis of the tube in which the objective is placed. The image of the star is further magnified by the eyepiece, consisting of the number of lenses and fitted in a tube T2. The arrangement is mounted on a stand. Now again the whole process is the same as in the Cassegrainian telescope. Light is from the distant star focused on a parabolic mirror, and it converges. Before it meet at the focus, they intercepted by the mirror, and mirror reflect the beam which is observed by the eye. Now it is the last topic of the ray optics. Thank you and have